We started out this module wondering how a detergent might help clean greasy dishes. It's actually a bit more complicated than you might think. But now that we have the language of hydrophobic and hydrophilic, let's work our way through how a detergent functions. Here are 4 different representations of sodium dodecyl sulfate, better known as SDS. A is a space-filling model, B is a ball and stick model, and C is the Lewis structure. The structure is reminiscent of the fatty acid we saw before. There is a hydrocarbon chain with 12 carbons and what appears to be a sulfate group at the right end, where one of the oxygens is bonded to the chain. The image in part D suggests a way to think about SDS, with a hydrophilic head group, the sulfate, and a hydrophobic tail, the hydrocarbon. Chemical species such as this are sometimes called surfactants, since they can act at the surface. If you put a layer of SDS on the surface of water, it can form what is called a monolayer. The hydrophilic head groups want to go into the water, but the hydrophobic tails don't, preferring to stick out into the air. And if you think about washing dishes, simply putting detergent into the water doesn't help. You have to scrub, agitating the solution. Literally, you're pushing the hydrophobic tails down into the water where they don't want to go. So what happens when the tails go underwater where they don't want to be? Being hydrophobic, they want to associate with other hydrophobic molecules. So they tend to aggregate and form what is called a micelle. A cross-section is shown on the left where the tails are pointing to the inside. Since SDS ions are conically shaped, when they aggregate, the micelle that is formed is spherical. This shape is perhaps more clearly seen in the picture on the right. Inside the micelle is essentially a microdroplet of a hydrophobic nonpolar liquid. This is covered on the outside by the hydrophilic head groups, meaning the micelle as a whole is happy to be in water. Now, as you are scrubbing, these micelles are opening and closing, opening and closing, opening and closing. If it opens and closes on the surface of a greasy dish, fatty acids and lipids would be happy to jump inside, enjoying the hydrophobic atmosphere, only to be washed away with your dishwater. Keep in mind that if this seems like a complicated process, it is based on the ideas of hydrophobic and hydrophilic, and on the simple rule that like dissolves like.